Hi everybody. Today we're going to talk about weather systems and different types of fronts that might be passing through your area. So often when you turn on the Weather Channel, you'll see a meteorologist standing in front of a screen that shows a map of the general region or possibly the whole country. Now, those weather maps show areas that have clouds or precipitation, but ultimately what we're going to be looking at today is where they have certain types of weather fronts. So to start off, a front is a boundary that separates two different types of air masses. Now, if you recall to the last notes that we took, we have our different types of air masses. You could have maritime tropical or continental polar or continental tropical, etc. When these two different types of air masses collide with one another, we often have storms that are associated with that. So you can think of a front as a place where two different boundaries collide with one another. So in this picture down here on the bottom left, you'll notice that there are two different types of air masses that are hitting one another where this blue line is that represents a front. We'll talk about what type of front that is in just a moment. On the left side, you'll notice that the temperatures are very cold and they're located over the central United States. So that is most likely going to be a continental polar air mass. On the right-hand side, you'll notice that the temperatures are a lot warmer and they're also near the coastline, so they're most likely going to represent maritime tropical air mass. So you have these two different types of air masses that are hitting one another, and often you're going to have different types of storms and things like that. So when you have a front, it's going to be associated with, number one, temperature change. The second thing that's associated with a front would be a pressure change. Often you have cloud formation, and that can lead to precipitation as well. Okay. All right, the different types of fronts have specific symbols that are associated with them. If you turn to page 13 in your ESRT, I want you to find out what each of these symbols is associated with and write them down on the side. Okay, so the first one that we see here is a cold front. And a cold front is going to be drawn in blue, and it has different little triangles on the bottom here. So you can think of these triangles as icicles, right? Icicles represent cold temperatures. The blue color also represents cold temperatures as well. The next one here is a warm front. And you can think of warm fronts with little tiny suns sticking out. So it represents warm weather. And of course, red represents warm as well. This next one is a mix of both of them. So you have the reds, you also have the blues. And if you notice, they're pointing in different directions, in opposite directions. That means that this is a stationary front. Stationary meaning it's not going in a specific direction. And then the next one down here is, again, a mixture of both of the colors, and they're pointing in the same direction. This is called an occluded front. Okay. All right, so there is a rule when it comes to the fronts and the direction that they move. If you notice on some of these examples here, the symbols are pointing in a specific direction. So the rule is the triangles and bumps always point, and we're going to write in the direction that the front is moving. So for example, if you look at letter A on top, the symbols are pointing downwards, so that means that the air mass would be moving towards the south. For letter B, if you notice, the symbols are pointing up, so that would be moving towards the north. Now if you look at letter C, you have some symbols that are pointing south and some symbols that are pointing north. Well, that would be the stationary front, meaning that it's not moving in either direction because they're pushing against one another. Okay, the first type of front that we're going to discuss is a cold front, but before we do that, I would like to look at a video that I found on YouTube.
This animation is going to describe how precipitation happens at what are called cold fronts and warm fronts. These are weather systems that develop wherever masses of cold air collide with masses of warm air. And the name actually comes from war, where armies would meet along a battle line called a front. And one way to think about the difference between cold fronts and warm fronts is to think about which mass of air is going to win the battle. So we'll start with a cold front. This is a situation that happens where cold air moves in like a big wedge underneath warm air. Cold air is always heavier than warm air, and so it's denser, and it's going to tend to slide under the warm air and push the warm air upward. Anytime you have air rising upward, it's going to expand and cool and lose its ability to hold moisture, and this will give you a band of clouds and precipitation along the cold front. On weather maps, if you watch the weather on the news, you can see cold fronts marked by lines of blue teeth that point in the direction the cold air is moving. Along cold fronts, you typically have very intense local thunderstorms and rainstorms, so it might pour rain for a short time, but then quickly, usually within an hour or so, the front will have moved on. So a cold front is where the cold air pushes underneath the warm air, and you have high rainfall and usually intense thunderstorms. Now, the warm front.
Okay, so if we go to the next slide, you'll notice we have two cities. One is covered with cold, dry air. So again, cold represents polar. So I'm going to change this color to blue. So this is polar, and dry represents continental, so CP. On the other side over here, we have warm, moist air. So that's going to represent maritime, tropical. Okay, and if you notice, the frontal movement is going to be from west to east. So in the United States, our storms always move from west to east. So I'll put move west to the east. So in City A, since City A is, I'll make this easier to see, City A is moving towards City B. Well, the air above City A is moving towards City B. So what's going to happen is, as this cold, dry air is pushing through, it's going to force the warm, moist air upwards. Right? Warm, moist air is less dense, therefore it's going to want to rise above the cold, dry air. And when it does that, if you recall the cloud formation steps, warm, moist air rises, the temperature cools to the dew point, condensation occurs, and then you get cloud formation. Now, because this happens so quickly, the clouds will be very tall and have a lot of energy, and you get really heavy bursts of rain. But generally, they only last for a couple of hours, so you get short bursts of heavy rain. Now, when all is said and done, City B will become colder and drier, just like City A. So let's write down some characteristics for a cold front. So number one, the temperature becomes colder. Okay, when the cold front moves through, you get short bursts of heavy rain, maybe only lasting for a couple of hours or so. You get tall clouds. Afterwards, usually becomes sunny and cool. So I'll put sunny / cool, and that's associated with high pressure. And high pressure also is associated with a continental polar air mass. I'm going to put takes over. Okay, so that would be for a cold front. Now let's look at warm fronts.
Has in common a couple of things with the cold front. One is that the warm air still goes up on top of the cold air, but in this case, the warm air is actually pushing the cold air out of the picture. So the warm air is winning, and that's how you can remember it. It's a warm front. The warm air pushes against the cold air, squeezing it out. Like imagine squeezing a watermelon seed between your fingers. It kind of squeezes out, right? And as the air pushes, it also rises up over the cold air. Rising air, again, loses its ability to hold moisture, and you tend to get clouds and rain. On long warm fronts, you typically have more mild, more mellow, more spread out rainstorms rather than really local, intense thunderstorms. And if you're looking at the weather on the news, they mark warm fronts on maps with red half moons that point in the direction that the warm air is pushing the cold air. So that's cold fronts and warm fronts, major precipitation belts in many places on the Earth.
All right, so we're looking at a similar map to the video, and I'm going to switch my, no. So you'll notice that the frontal movement is also going towards the east, so always from west to east. And in this case, we have a warm, moist air mass, so this would be maritime tropical. Over here, we have the cold, dry air, so that's continental polar. Now, the warm, moist air is going to be pushing the cold air out, but because warm air is not as strong as cold air, it does this a lot slower. Now, when that warm, moist air comes in and it hits that front, it's going to be pushed upwards. And again, when you get that warm, moist air rising, you get clouds. But if you notice here, these clouds are more spread out, which means that the rain is going to last for a lot longer period of time. So if we look over here, for warm fronts, the temperature becomes warmer. Also, you're going to have long-lasting precipitation. Okay. You're going to have long, stretched-out clouds. The air pressure is going to drop also. So air pressure becomes low. And low air pressure is associated with a maritime tropical air mass. Okay. All right, let's look at the next type of front, which would be a stationary front. Stationary is exactly what it sounds like. So stationary is two fronts that are basically colliding into one another, and they're not going to move. So stationary front can last for, we'll say, days or week, maybe. And you're going to get heavy rain I'll put heavy precipitation. Heavy precip slash long lasting. Okay. An occluded front is something where you have a cold air mass being pushed out by a warm air mass, but there's a cold air mass behind that even. So what happens is that warm air kind of gets squeezed up between the two cold air masses. Now when that happens, you also are going to get heavy rains. That symbol is going to be represented with purple. So you notice that the occluded front is drawn in purple here. Oh, let me go back actually. So when that does happen, you also get something called a mid-latitude cyclone. So let me draw this for you. So here you have your low pressure zone, right? If you remember, it's going counterclockwise and in towards the center. And when it's rotating, that warm air mass, or warm front, I'm sorry, is going in this direction. So it's spinning counterclockwise. But you also have this cold front behind it, and because cold fronts are faster, it's going to eventually creep up with the warm front and take it over. Now when that happens, we call this a mid-latitude cyclone, and you can get really large storms. If this happens in the wintertime, this is usually when we have really, really heavy and long-lasting snow. So this is what it looks like from a side view. So you have this cold air being pushed out by the warm air, but at the same time you have a cold front catching up to the warm air, and that's going to force that warm air upwards. You get really big clouds, really heavy storms. So mid-latitude cyclone, this is a side view, and this would be a top view. Okay, so again, you can find in your reference table the symbols for the fronts down here, so you don't necessarily have to memorize them. So take a look, get familiar with page 13. It basically sums up all of the weather unit that we're going to be discussing.